Okay, the first part of FRQ number 4 was, or Q4, was Euler's method. The primary issue I saw with most of what I saw was the arithmetic or use of the x instead of the y for your derivative. The first part here, first of all, it says two-step. It says start at 0 and go to a half. That means your change in x has to be 1/4. Your derivative is based on the y's, so y squared minus y gives you 2. I'm sorry, gives you 4 plus 4 is 6, apologize. And then 6 times 1/4. Now again, we don't have to worry about reducing, but you can do it however you want to, but it's 3/2, which gives you a new point. 0 goes to, you add the 1/4, it's 1/4, and then you take the y -2 and add 3/2 gives you -1/2. Now you start with your new point, and you find your derivative. Now again, it's based on the y, so it's -1/2 square minus -1/2, which is 1/4 plus 1/2, which is 3/4. So your derivative is 3/4. Your change in x is 1/4. Multiply these two together gives you 3/16, creating a new point of 1/4 plus your change in x is 1/2. -1/2, just do some side work here, -1/2 is -8/16 plus 3/16 gives you -5/16. Your resulting answer is f 1/2 at 1/2 is approximately equal to -5/16. That's part A. So take a look and see where your flaw was, if you made any at all. This one is really important. Some of the statements may need to be rectified because you understand it is just simply you're getting the wrong answer. If I plug in 0, I get f of 0. This is, by the way, find the limit of this. You can bet you're going to see a L'Hopital's rule. So plug in 0 plus 2 over 2 times 0 cosine 0 is f of 0 is defined to be -2, so this is -2 plus 2 over 0, which is 0 over 0. L'Hopital's rule applies. You need to write that statement. Of course, spell it correctly, please. Just kidding. So now I need to take the derivative. Technically, if you want to show this is actually L'Hopital's rule applies, technically you should write that the numerator equals 0 and the limit as x approaches 0 of the denominator equals 0. That's the correct way to show that L'Hopital's rule applies. You have to actually state that both the top and the bottom are equal to 0. That I've seen them accept this, but some professors and some readers might be less interested in being fair about that. Now, what we got to do next is, because L'Hopital's rule applies, is take the derivative. I want to emphasize a couple things here. One, look at the denominator. That's a product. You got an f times g, fig e. The top is the derivative of x, which is given right here. This is your f tick x plus 0 over, now I'm going to do my product rule, f tick g plus f times chain rule. Cosine u is negative sine u times derivative u. Now I'm not going to simplify that as it is. I'm just going to go ahead and plug in 0. So I've got f tick 0 plus 0 over 2 cosine 0 plus 2 times 0 times, that all winds up being 0, so I can just put 0 there. Okay, issues right here. Okay, see, you can't come up here and plug in 0 up in here, because up in here, that's 0 is an x, not a y. You need to plug in y when x is 0. That means you need to plug in the negative 2. Again, a lot of people are plugging in 0 up here, but it's not 0. You can't plug in x. You have to plug in the y. And they give you that when x is 0, y is negative 2. So when I do this one, I'm going to plug in negative 2. I get negative 2 squared minus negative 2, which gives you 6 over 2 cosine of 0. Cosine of 0 is 1. Answer 3. Okay. This next part is huge, weighed out, and I'm confident that you'll see one where you have to do this. This is where we need to solve this for y. In other words, we need to get rid of the derivative. It says you don't have to solve it in this form, so that's a plus. So the commit allows you some variation in how you do it. But the first key thing is you need to separate the variables correctly. Okay, so if I want to get the y's of there, I have to divide by y squared minus y on both sides. So this should give me 1 over y squared minus y dy equals 1 dx. You have to write the statement. It has to be written. Without this, you pretty much lose points, even if you seem to know what you're doing. The second thing is, you can't take this and say this is u. If you let this be u, I'm going to scribble a little note here. If I let u equal y squared minus y, and then you do du equals 2y minus 1, where the heck are you getting that? That's not going to be there. You can't, it's not u substitution. Almost guaranteed you're going to get an A-B question, and that's what this is. So a little side work here. I'm going to do, this is equal to a over y plus b over y minus 1. Which means 1 equals a y minus 1 b y. Okay. Value of y is 1. Gives me b is equal to 1. If I plug in 0, I get a is negative 1. Come on in. Now that I have my side work done, this becomes the integration of negative 1 over y plus 1 over y minus 1 dy equals integration of dx. It's probably best to switch the order here, but now I have 1 over u, 1 over u. Okay, if I integrate this, so if I integrate, of course this is a whole nother point, negative absolute value of y plus ln absolute value of negative 1 equals x plus c. Subtraction, I probably would rewrite this because I'm going to change subtraction of logs into division. Okay, and that's a good form to be in. I don't really want to, I mean, I could solve for e. I guess I could do one more step here. Y minus 1 over y equals e to the x plus c. Y minus 1 over y equals c e to the x. Okay, now I like this form. Now this is pretty good, but I don't want to go any further because solving for y is a pain in the hemorrhoid. So now I'm going to apply the point 0, negative 2. That gives me negative 2 minus 1 over negative 2 equals c e to the 0. So c equals negative 3 over negative 2, or just 3 halves. Now, here, the nice thing is they said not necessary to put it in the fx form, in the y equals form. That means I can just take my c, slide it up in here, and rewrite the answer to be this. Okay, it's extremely important you follow through with all your, go through all these videos and make sure, because you will see these on the exam.